goal for this lab was to use AC power to light an LED array. There are several different ways for doing this, each with their own advantages and disadvantages. The first and second design that we constructed are both simple to design and do not use many components, but half of the AC power is wasted in both designs. The first design we used a single diode and an array of LEDs wired in series to provide the correct voltage and protection for the LEDs. A protection diode is necessary because the LEDs have relatively small breakdown voltage, meaning that if the negative side of the AC wave were to hit the LED, it would cause a failure. The 1N4007 diode, on the other hand, has a breakdown voltage of 50 volts, meaning that the LEDs will be protected from the negative side of the AC wave. The downside of this design is when the AC wave is negative, the LEDs are not lit. At a frequency of 60 Hz, this is not noticeable, but it's only 50% efficient. The second design uses two diodes and two LED arrays, one to use the positive side of the wave and one wired in reverse to use the negative side of the wave. The benefit of this design over the first is the four LEDs remain lit at all times, meaning that there's not a noticeable pulse, but this design still only has 50% efficiency.
The third and our final solution provides a way to produce a DC current more efficiently through use of a circuit called a bridge rectifier. Through the use of four diodes aligned as shown on our breadboard, the negative half of the AC wave is flipped back to positive, providing an almost constant positive voltage. This design can be improved even further by adding a capacitor in parallel to the load connected to the diodes. Because the negative AC voltage is just inverted, there is still a small drop and rise of the voltage between cycles. Adding this capacitor allows a small amount of energy to be stored to stabilize the voltage during the drop, creating a flatter voltage response. This design is almost as simple to build as the first two, and it has a much higher efficiency. Using our AC transformer, we were getting a constant DC voltage of around 16 volts between our bridge rectifier. We created 5 arrays of 4 LEDs wired in parallel and wired these arrays in series. This gave us just over 3 volts to the LEDs, ensuring that they would be bright but not overpowered. Once we wired everything up and connected the AC transformer, we had a working array of 19 blue LEDs and 1 super bright LED that was running off of a converted DC signal.
My name is Jason Semien,
And my name is Prather,
and this is our Lab 7.